Hello all. In this tutorial we are going to see how to install OpenCV with CUDA support on NVIDIA Jetson Nano. To avoid lengthy videos, we have divided this tutorial in two parts. In first part of this tutorial, we have seen brief theory about what is CUDA, what is an OpenCV, why we need OpenCV with CUDA support for Jetson Nano, what are the prerequisites, and so on. Now this second part of this tutorial is all about demo and practical session. We will see how to enlarge the memory swap of Jetson Nano, which will help us to build OpenCV from its source. Then we will see how to build and install OpenCV on Jetson Nano using a single installation script. And finally, we will also test WebCamera and CSI Camera with some cool OpenCV object detection programs. Therefore, we would like to advise you to first watch the previous part of this tutorial to understand the theory, concepts, and procedures behind this tutorial. Then come back to this second part to watch the video of demonstration. So without any further delays, let's get started. So you can see, this is a tutorial guide to resize and enlarge swap memory of Jetson Nano. You will find link to this repository above here on top in address bar. Don't worry, we will share it in video description. So, there are two main tasks we are going to perform before going into installation of OpenCV. First, we will resize the default size of swap memory for Jetson Nano. Then we will increase the swap space. So, many people may find these statements confusing and you must have been wondering about what we are talking about. But please don't worry, you will understand along the course. So let's start with resizing the swap memory. For that, let's log in into our Jetson Nano. We will use PuTTY software to remotely log in into Nano via SSH. Then enter your credentials, means username and password correctly to log in into Jetson Nano. Once you logged in successfully, check for any updates available. Run both update and upgrade commands. For the time being, we will skip the upgrade step, since we have already upgraded our system. But you should follow if you haven't done it yet. Then next, you can run either JTOP or free command to see the available memory of your Jetson Nano. So as we have 4 GB variant, you can see our configurations here. 4 GB RAM and 2 GB swap space, which is delivered by ZRAM. So as given here, the swap memory allows for extra memory when there is memory pressure on main physical memory by swapping portions of memory to disk. Since the Jetson Nano has a relatively small amount of RAM memory, which is about 4 GB or 2 GB for other variant. This can be very useful, especially when, for example, compiling large projects. Here, the swap memory method in use is a ZRAM. You can examine the swap memory information by using following command: zramctl. So let's execute this command in terminal and see the results. So you can see, as we said earlier, you will notice that there are 4 entries, one for each CPU of the Jetson Nano. ZRAM 0 to ZRAM 3. Each entry has an allocated amount of swap memory associated with it, by default 495 MBs, for a total of around 2 GB. This is half the size of the main memory. You will find this to be adequate for most tasks. However, there are times you may want to adjust the size of swap memory. like for installation of OpenCV. So how you can change it? The configuration for the ZRAM allocation is done at system startup. The file that controls this configuration is this one. We have to modify this equation in that file. For that, we need text editor. So first we will install the lightweight text editor called as Nano. You can install Nano Editor using this command. Okay, now we can edit that config file. Let's open that file in Editor window. Here is the one. So the size of the ZRAM for each CPU is calculated by this line. Where total mem is the total amount of memory, and NR devices is the number of CPUs. Basically, it divides the amount of physical memory by the number of CPUs with a divisor, in this case 2, to get the 2 GB in total. You can simply edit this equation using a text editor. Please note you should make a backup of the file first, just in case, and you will need sudo permissions to change the file. So you can see, as we have explained on this guide with these screenshots. So in order to get full potential of memory, you have to remove the divisor to get a full 4 GB memory, which is a ZRAM swap memory. So we have to remove this division by 2. You can refer given screenshots for more details. Once you edit the file correctly, press Ctrl-O to write the results. And then press Enter to save file. And finally, press Ctrl-X to exit out of the editor. Now we have edited the config file. But for changes to take effect, we have to reboot the Jetson Nano. Let's do that. We have rebooted the Nano. Now let's log in again. After reboot, if you see memory again by running free or jtop command. You will see our changes have taken effect. ZRAM swap sizes now became 4 GB. Now let's go forward and perform second task, which is enlarge the swap memory. So you can see in these results, we have now total around 8 GB of memory, 4 GB RAM and 4 GB ZRAM swap, but you can see it is not totally 8 GB free, isn't it? So please note that for building latest OpenCV from its source, with utilizing all 4 cores of Jetson Nano, we require at least 8.5 GB memory, that is RAM plus swap. So, we are going to use one more tweak to enlarge the Jetson Nano swap memory, since our Nano's default memory. 4 GB of RAM plus 2 GB of swap is not enough for a quick build of OpenCV. Now suppose if you do not want to enlarge the swap, and if you run quick build without enlarging swap memory, then it will run, but will take quite a long time. Since in this case, the compilation will be done by only 1 core, hence it will take time to build. So it would be best if you had more memory allocated to your Nano for the fast 4-core build. So, we have already resized our Nano's default swap size to 4 GB. By using ZRAM method, which is given above, now we will use DPHYS SwapFile package method to add additional 2 GB, so that total swap memory will become more than 8.5 GB. That is, 4 GB of RAM plus 6 GB of swap, approximately around 10 GB, which will be enough for quick build criteria. Before going forward, please note very important thing here. The recommended swap memory size for Jetson Nano is 2 GB. Larger swap memory sizes can sometimes cause decreased performance. It is recommended to use a swap file, in addition to swap memory, if you need larger amounts of memory for building projects. For the time being, we are going to tweak with the system files to increase the memory swap, only to achieve the faster installation using additional swap memory. So, we will restore the settings to original after completing installation of OpenCV. Okay, so we already know this. Currently in our case, we have these memory capabilities. We have to add at least 2 GB to make our system eligible. Please do not add more than 4 GB. System may behave uncertainly. Now let's install the SwapFile package. This package will help us to utilize our SD card's free memory. For that we have to run this command in terminal, which will install the package from internet. Okay, now SwapFile package got installed. Now let's edit 2 important system files to enlarge the boundary of swap. Use this command to edit the DPHYS swap file using Nano Editor. So it will get opened here in terminal. In this swap file, you have to mention how much size of SD card memory you want to utilize for swap purpose. So in our case, we need 2048, means 2 GB, which is sufficient for our purpose. We have shown these all settings in these screenshots with thorough details. Please refer them if you have any queries. In this line, you have to put here as CONF swap size equals 2048. Okay. As we said earlier, here you can increase it up to 4096, that is 4 GB maximum recommended size. But for us, currently 2 GB is sufficient. Very important. Please note, you must have that much amount of free memory on SD card, which you are going to opt here for swap memory. Otherwise, system files may get corrupt. So you can also refer these screenshots for more details. Okay, now let's write the file by pressing Ctrl-O. Then press Enter key to save the file. And finally, exit out of Editor by pressing Ctrl-X. Now next step is, we have to edit one more file, which is in another folder. So copy this command, paste it in terminal, and execute it to edit this file. So please note here, the file we edited earlier was located in folder named sbin. You can see and confirm it here in screenshots, and also in command description. Whereas the command which we are going to edit now is in etc folder. Isn't it? So there are 2 different files at 2 different locations. Please do not get confused here. Alright, now here in Editor, like we have shown in screenshots, you have to write value CONF swap file equals 2048, which should be similar to which is put in earlier file. If in case you find this line commented, then you have to uncomment it by removing hashtag symbol and then write this config line. Okay, once you write correct value in file, save the file by pressing Ctrl-O, then press Enter. And finally, exit out of editor by pressing Ctrl-X, like we did for earlier file. Now we have to restart the system for changes to take effect. So let's do that. Enter this command in terminal to reboot the Jetson Nano. Okay, now after restart, log in with your credentials. Then, let's check memory by using free command, or JTOP command. You will see, now RAM equals to 4 GB, and swap equals to 6 GB. Total memory equals to approximate 10 gigabytes, which is enough for our OpenCV quick build limit. Okay, so this was about how to enlarge the swap memory of Jetson Nano. Now let's go to another guide, which is the main objective of our tutorial. That is, building OpenCV from its source to get CUDA support. For that, let's get back to root folder of repository. Here, this one. So here in this repo, we have to go to another folder, OpenCV installation scripts. This one. When you enter in this folder, you will see another README file with detailed guide about instructions, procedure with screenshots and commands. So you can see here, these all are scripts to install all these versions of OpenCV. You can choose according to your preference. Starting from OpenCV 4.5 to latest version. You can choose any version. So as given here, installing OpenCV on your Jetson Nano is a time-taking procedure. By installing all the dependencies and required packages one by one using command line, with its around 70 command lines, it is more of a lengthy administrative task. That's why we created an installation script that executes all commands in this guide at once. Use it if you want, it should not cause any problems. The whole installation will take 2 to 3 hours to complete. You may have to give authorization to some commands in between installation. Let's go to the first step, which is check available memory, using free command. So as we said earlier, if you want to quick build OpenCV by utilizing all 4 cores of Jetson Nano, you must have at least 8.5 GB memory. RAM plus swap. If you still have not enough memory, or you have not covered earlier part of this video, please go to this link to enlarge swap memory. So you can see here in terminal, we have enough memory. Now here comes easiest part. You just have to copy and execute this wget command, which is nothing but a link to download the script file, which we have given here on repository. So let's first copy this command and paste it in terminal, like this. Here, pay attention if you want to use any of these versions of OpenCV. You have to put its specific name in the command. For example, let's say we want to download script for installation of OpenCV version 4.8.0, so you can write here like this. So, the latest version script will install latest dev version of OpenCV. If you go further in the script file, you will see it is nothing but a simple bash script of sequence of different commands to install dependencies and required packages one by one. Okay, let's get back to previous window. So you can also use this guide of installation of OpenCV, and this script named latest OpenCV for latest version of Nano hardware, which is nothing but Aura Nano. We haven't tested it yet on Aura Nano, but it will surely work similarly as of our Jetson Nano. Let us know if you find any difficulties in doing this. Now here, for demo, we will download the 4.9.0 version of OpenCV. So let's execute it in terminal. So you can see in command we have written the name of that version, 4.9.0 in wget file. Please recheck and re-verify it from script files given here. The script file will get downloaded. Let me show you. Here is the one. Then, to execute this .sh script file, you must have administrative, means super user privileges. So let's change permissions of this file. Use this command named chmod. Then next is execution command. This command will start building an installation of OpenCV on your system. There must be an internet connectivity, since it will download the required packages from internet. Okay, once you execute this command, it will take 2 to 4 hours to get complete, depending on our hardware configuration. When we made this tutorial, it took around 3.5 hours to complete. Now let's see the demo. Let's execute the command in terminal, so it will start downloading required dependencies. We will fast forward this video until the point where we need to give some input or some authorization. Okay, so this screen came after approximately around 3 hours. Here you have to enter your password. We have shared the screenshots for these windows. You can see those in our reference guide. Now let's enter the password and go ahead. So finally, you can see this message that your specific version of OpenCV got successfully installed on your system. In our case, it is OpenCV 4.9.0. Okay. Now as we have successfully installed OpenCV on our Jetson Nano, let's free or clean the memory which we used for that. To make some space and to restore the tweaks which we have done in system files, we have to do some work. So in step 5, here, let's first remove downloaded script file. Here is a command for that. Let's copy, paste, and execute in terminal. Then next, let's edit the zramconfig file, like we did earlier, using Nano Editor, and restore its original settings. Please refer these screenshots given in GitHub guide for more details. Here you have to add division by 2. Here, let me do that. Okay, like this. Compare it with screenshot. Is it okay? All right. Save and exit. Now next step, we have utilized SD card's memory as swap. So let's remove the swap file to free that memory. Then we will also remove the SwapFile package, since we do not require it anymore. Then next, you can save more space by removing installation files. And finally, to all these changes to take effect, let's reboot the Jetson Nano. Okay, now system is rebooted. Let's log in again. Now, how you can verify that OpenCV got correctly installed. Let's check. For that, in Terminal, open Python prompt. Here in Python, import OpenCV package. Like this. Okay, then let's print its version. So you can see, currently we got OpenCV 4.9.0 is installed on our system. Okay, now we have installed OpenCV on our system, but we haven't tested it yet with real image or video processing applications and haven't confirmed its correct working, isn't it? So for that, let's connect the cameras to our Jetson Nano. We will use two cameras, Raspberry Pi CSI Camera and Logitech C270 HD webcam. You can see the setup. So, we have discussed in our earlier tutorial about how to install and how to use No Machine remote desktop software for Jetson Nano. If you haven't watched it yet, go and watch that tutorial to install the No Machine. So we will open No Machine client software on our Windows system. Log in and access Jetson Nano's desktop, like this. Okay, now here in this folder, we have given some Python codes. There are two programs which can be used to test the cameras, which uses OpenCV library to access the camera live streams and display it here on desktop. Let's test the working of two cameras first. We will share these codes on our GitHub repository. Links will be given in description of this video. So as we have seen, our cameras are working. Now let's run another Python program which we have given. This code is of red ball tracking application, which detect red colored ball in live streaming video frames of camera and create bounding box around it and tracks it in that given frame. Alright, that's it. This is the second and final part of this tutorial. To avoid lengthy videos, we have divided this tutorial in two parts. In the first part of this tutorial, we have seen brief theory about what is CUDA, what is an OpenCV, why we need OpenCV with CUDA support for Jetson Nano, what are the prerequisites, and so on. In this part of the tutorial, we have seen about demo and practical session. We have seen how to enlarge the memory swap of Jetson Nano, which helped us to build OpenCV from its source. Then we have seen how to build and install OpenCV on Jetson Nano using single installation script. And finally, we have also tested WebCamera and CSI Camera with some cool OpenCV object detection programs. In our upcoming projects, we will use OpenCV to create some amazing computer vision projects. Stay tuned for more projects and tech updates. If you face any difficulty in replicating our DIY projects, feel free to ping us on Telegram or WhatsApp. You can also send us email at info@make2explore.com. We would be happy to help. Thank you.